Awesome. We are good to go.
Excellent.
Cool. So, as everyone probably saw if they're in this event, we're doing a live code walkthrough today with Royco, Jack from Royco, whose competition also kicked off today earlier. So, Jack, I'd love if you could get started just by, giving a brief intro to both Royco and yourself, your role on the team, and yeah, whatever else you'd like to add.
Awesome. Hello, I'm Jack. I'm the tech lead for the Royco Protocol. Royco is we're kind of building markets around on-chain actions, mostly liquidity provision actions. So I think it'll be kind of a good primitive for sourcing liquidity, finding efficient price liquidity, and I'm excited to show it to all you guys. Yeah, we'll go right ahead. And I think it lets me full screen. Okay.
Perfect.
Right here. How does that look?
Loading, but it looks, yeah, we should be good now.
Okay, cool. Can we see this okay?
Yes, I can. Is everyone in the audience good with that?
Go ahead and say no news, good news.
Yeah,
Um,
perfect.
yeah, so so thank you all for kind of coming and taking time to review the code base. I think hopefully there's some good findings. The code base is kind of split into two major pieces. We have two types of markets that Royco supports. So we have, like I said, Royco is kind of a protocol for sourcing liquidity, and we have two kinds of markets that we are kind of and specifically we're trying to find. We have order books. We have order books which are you can place orders saying like, okay, you would need to pay me this much in incentives in order for me to deposit my liquidity into your protocol, or more generally to do kind of like any arbitrary action. It does not have to be LP actions. Uh, we have these order books for negotiating incentives on all sorts of things, maybe bridging to a new chain or minting an NFT or all sorts of stuff. The general idea here is that we're trying to find efficient pricing for like how much incentive spend you need to make in order to have certain actions happen. And we have two kind of main types of actions. We've got recipe actions, which is here in recipe order book. And also we have vault actions, which is here in vault order book. The difference between these two is vault orders, we have you're expressing how much. We have kind of these unipool style staking vaults, where you are depositing in a 4626 vault, and then you are being streamed some arbitrary token incentives. Also, you could be streamed points, which is done just via events. We'll talk about later. But generally, you're saying I will deposit into this vault if the if the token stream surpasses some threshold. You could say like if this vault starts paying more than maybe you're depositing income, right? And if you're going to pay me more than 1,000 comp per day in order to be deposited in this vault, then I will deposit into that vault, and my funds will be there. And then maybe I can collateralize another order with my compound position. I can say, okay, now I'm currently in compound, and I would like to deposit into Aave, but Aave is going to have to pay me, this many Aave tokens, and if the Aave the Aave token streaming surpasses some threshold, then I'll pull my funds out of compound and deposit them into Aave. So also feel free to stop me at any time if there's questions. I don't know. I'm pretty unfamiliar with Discord stages, but I'll try to periodically check the Cantina stage chat to see if there's any questions. So the way that we have this, we have these. There are people who are depositing these vaults are no longer called liquidity providers. We're now calling them action providers. They're called action providers because it might not be necessarily a action that you or sorry a liquidity provision deposit. You might just be like bridging or minting things that aren't LPs. So we have kind of this generalized action provider order. These AP orders are not stored on chain. In order to have gas efficiency, we actually hash these. At the very bottom, we have this get order hash function, takes the struct and returns the kekak hash of it. And what we do is we store these orders in this mapping that maps your order hash to how much quantity is remaining in the order. So we don't store all of these things on chain. The idea is that you're emitting them as events, and then you're recovering the values from the events, meshing them together, and interacting with the vault order book using the order hashes. Specifically, if you look over here at create AP order, you can see you pass back in the parameters of the order. So if you take these parameters and we're recovering, so you're getting all of the things that would have usually been stored on chain. We're now recovering them by passing them in as call data. And then if we hash them and the hashes match, or the hashes, if the hashes match, then we know that that was in fact a correct order that was placed at some point in time. We can see how much quantity is remaining on that order, and then we can do things with it. When I'm talking about quantity, I'm talking about quantity of deposit token. So if you're in my compound example, if we're going to deposit the compound, maybe the asset that I'm depositing is DAI. So what I would say is the way that this AP order would look is this is a target vault. This is like your compound 4626 vault that we have wrapped, which I'll show you in a second. Here's a vault that I'm going to pull my funds out of, right? Maybe I'm placing an order on, maybe I currently have funds in Aave. So I'm going to point this to my Aave vault. And then in order to make that, withdrawal and deposit, you need to pay me these tokens at these rates. Tokens requested. So maybe this is like, you need to pay me comp, you need to pay me WETH, and you need to pay me some like points program, which we can also express as if it's like an ERC20. So that's kind of our AP order. I'm going to show you, I'm going to take a minute to jump into ERC4626I, which is our wrapper around 4626 vaults. We have, because 4626 does not natively support incentives, we have this wrapper contract called ERC4626I, the I standing for incentives. And ERC4626I allows us to kind of do that Unipool style, incentive streaming to people who have deposited in the vault. So this is forked off of, actually that's irrelevant, an Alquaca contract called ERC20 rewards, where you're giving Unipool style staking on holders of a token. And then we have the mint permissions of that token is controlled by the ERC4626 deposit. So if you look down here, here we have like you can see your deposit function into the ERC4626I. What it actually does, it takes your deposit asset, it pulls it into the ERC4626I, and then it deposits it into an underlying vault. So we have kind of a ERC4626I is not a vault. It has all the same functions of a 4626 vault, but the vault itself actually just points to, if Compound already had an ERC4626, they would not have to deploy a new one in order to interact with Royco. They would just simply deploy an ERC-4626I wrapper, which deposits into their vault, and you only are eligible for incentives if you've opted or if you've deposited into the compound vault through Royco. So here's a deposit function, and you can see it's depositing into the underlying vault right here. The actual incentive streams that I mentioned are handled here-ish. We have kind of your standard Unipool style accumulators and whatnot. We have some mappings in order to kind of like track all of these accumulators. And then what we have is we have this whole contract is owned by the deployer. So, maybe Compound comes to Royco and they deploy this wrapper. Compound's now the owner of this, and they have permissions to add a new rewards token. So we can support any arbitrary tokens. If you wanted to say, okay, we're doing incentives in comp, and now we're going to change it to we're doing incentives in some other token, you could add that here. And you can also set rewards intervals here by saying, here's a token, here's an address that we're going to do a rewards campaign for. It's going to start and end at this time. We're going to distribute this much. And we also have fees that are set by the front end, which is calling this function. You have kind of like in the Uniswap router when you have a parameter in the Uniswap router which says like, okay, this is the front end which brought this deal flow, and we're going to pay some fee to it. We have the same thing. We have a front end fee recipient which receives some fees when a rewards interval is created, and later on when orders are filled, we take a fee there. We have, you can see kind of we're just adding the, setting up a new incentive campaign, taking the fees out, calculating rate, all your standard Unipool style staking things. We also have this function that allows you to extend a rewards interval. Basically, it's important that you're able to increase incentives at any time. So we didn't want to have a system where you have to wait for the end of this interval in order to start a new one. So you can kind of force end an interval and deposit, an increase in incentives into that campaign via this extend rewards interval. It allows you to say, okay, this is actually going to end at this new point. We're going to add this many rewards to it. And the catch is that the new rate has to be higher than the old rate. And this is because of work in the order book where if you were able to spoof a super high rate for a short amount of time, maybe you say, we're going to distribute, $1 million worth of tokens over the next week. And then you actually change it and say, never mind, that's actually going to be for the next year. And all of a sudden now people's rates have decreased. We don't want that to happen. So we make sure that the rate increases if you're going to tamper with a running rewards interval. Yeah, so then everything else here is just kind of calling your accounting functions on top of your different ERC20 functions. And we have this preview rate after deposit function. So this says, if I were to deposit this many assets into the vault, or I guess words, preview rate after deposit, reward assets. Yeah, if we deposit this many assets, then let's just get used. Oh, yeah, sorry. Because all of our different campaigns are different tokens, you have to specify in each one of your functions which campaign you're talking about. So if you're saying like, how much would it be in the compound campaign if I were to deposit, this many DAI? So this address would be compound because we're emitting compound, and this is DAI. And then if your compound was also emitting, points, this would be the address of the points campaign, and then this would be the address of the deposit, or sorry, the amount of deposit asset that you're putting in. So the reason why we have this function is because you deposit people into what you do is on the order book, you specify, okay, I want these tokens at these rates. And then we have this allocate order function, which checks right here it iterates through each of the tokens that you want, and it says, it calls this preview rate after deposit tokens to say, okay, if this order could be fully allocated into, or if this quantity could be fully allocated into that vault, and the rates that this person is receiving stays above his preferences, then we'll say the order conditions are met, and we will, withdraw him from one vault, deposit him into the next one, and move on. So this is the only point where 4626i is actually interacting with the order book, is it's just making sure, hey, is this user actually receiving the rewards that he wants? And if he is, then we can deposit him into that vault. Important to note that there's not price discrimination here. We're still prorating all of the incentives that are being paid through all stakers to everybody who's in the pool. So even though, if I say I'll deposit into this pool, if it goes above 10% APY, and it goes to 11%, and then I get allocated, a few days later, I might be at 9% APY, and even though it's below where I originally wanted, it's up to me to go place another limit order in order to pull, or, monitor that myself. Just because there's too many problems that you get into if you try to like automate people to be attack vectors, etc. Let's see. Yeah, so you kind of flow in Vault Order Book because you're creating the orders, and then a action provider creates orders, specifying how much they need to pay in order to do something. Then an incentive provider deploys one of these ERC-4626i vaults. They put incentives on people holding their or deposited into their 4626 vault, and then once we have a match, we allocate orders, and then they get deposited. They get pulled out of whatever vault they're collateralizing the order with, and then depositing into whatever order or whatever vault we placed an order on. Hopefully that all makes sense so far. Here's our points contract, which I've mentioned a few times that we can pay people points instead of tokens. We have this points contract, which does not have any state. It does not, track how many points we have awarded to each person. All that we're doing here is we have some, some kind of admin functions that make sure that you're not calling the points awards functions, which is just right here, you don't have just anybody calling these award functions. They can only be called by whoever you've authorized. And the way that this works is all it does, it just emits this event, this award to amount event, and then an off-chain indexer can go iterate through all of these and calculate how many points someone's been awarded. But obviously we didn't want to just like make this look like an ERC-20 or have any state, because we don't want anyone to, deploy an actual ERC-20 for your points program that isn't live yet and speculating on that. So this is kind of this thing that looks kind of like an ERC-20 and can be used in places where an ERC-20 is expected, but all that it does is emit this event that says so-and-so got to this many points. And then we also have our 4626i factory, which deploys all of our 4626i vaults and keeps track of them. And this is also where we have our fees. So in addition to the this is the front end fees, minimum fee, same thing. But not only do we have the front end fee, we also have the protocol fee, which is saying not only is there some fee which is paid to an address which is specified on function call, but you also have this protocol fee which is built in and directs some of the fees towards some protocol controlled event address. So same thing kind of with Uniswap, where you have like the Uniswap protocol fee, and then you have like the Uniswap Labs fee. We've got the same kind of like split. Okay. Unless we have any questions on the vault side of things, I'd like to introduce the second type of market that we have. The second market is recipes, is our recipe markets. Our recipe markets use a pretty interesting library called Wayroll. If you've seen Wayroll before, Wayroll is, let me go to it. Wayroll is a functional scripting language where all of the function calls are contract interactions. Basically, if you've ever used something like Gnosis multi-call or maybe DeFi Saver transaction recipe builder or the Instadap kind of like transaction builder, you have a bunch of different ways to call multiple different transactions at once. Maybe I want to swap my tokens on Uniswap for something else, and then I want to deposit the tokens that I get with the compound. If you wanted to do something like that, you usually can't with something simple like multi-call because you don't have a way of like keeping your return values and like propagating those forward um, to your future function calls. So you're always going to leave some sort of dust. If I was going to swap my tokens and then get the number of tokens I output and then use those for something, then you can't just like hard code those values. You need to recover those values from the return types of earlier function calls. So Wayroll is kind of a framework for doing that. They're doing exactly that. And this is out of scope, but kind of this very interesting style of you have this virtual machine which can execute different function calls. Highly recommend you check it out if you haven't seen it before. It's pretty neat. But what we use it for is we use it to have something similar to the vault markets where we're paying you incentives in order to do something, but now the something that you are doing is very generalized. Instead of saying you're depositing into this vault, you might be saying, I want you to, mint this NFT or swap and deposit on Compound or any complicated compound set of function calls. So it allows us to be very expressive and kind of cover all of the long tail things that you might not be able to do with vaults. Obviously, we don't want to be calling arbitrary function contract interactions from our EOA. So what we do is we have these Wayroll wallets, which is a super lightweight wallet, which you can kind of deploy using clone with immutable args pattern. And then you can have that wallet call you can transfer your liquidity tokens to it. You can have that wallet call your script. And then once you're done with it, you can just dispose of this wallet. It doesn't really matter. It's super lightweight. It's not a fully fledged EOC 4337 smart wallet. It's just a super lightweight thing, kind of act as a safety barrier between your EOA and whatever Wayroll script you're interacting with. So on our recipe order book, you can see, if I go to markets, we have these Wayroll markets, and each market has an input token, some amount of lockup times. What we'll do is like you'll do some action specified by our Wayroll script, and then after that action is executed, we'll lock your whole wallet for some period of time. Maybe we wanted you to bridge to a chain and then lock for a year, or a month. So then what you do is you'd specify a recipe. Here's your deposit recipe, which deposits you onto the chain. Here's a withdraw recipe, which is technically optional, but like this is how you get your funds back. And then you would lock it for a month. So it allows us to kind of express all these long tail actions, and then also say if we want locked liquidity, we can lock the whole Wayroll wallet itself, prevent anyone from interacting with this, and then you've effectively got locked liquidity. Okay. Same thing. Now we have our action provider orders where you're saying I want this many tokens at these values in order to do this action, in order to execute this recipe. We also have incentive provider orders now, which is so instead of an action provider saying pay me this much in order to do this, you can also have a protocol come and saying, okay, we're going to pay the first this many people who do X. And we'll pay you Y to do so. So we kind of have both sides of the order book now, and this now looks more like a traditional order book in the sense that we have kind of people on one side and then who are making offers, and people on the opposite side of the order book who are countering with more expensive offers. And you meet in the middle somewhere, find efficient pricing for whatever action it is that we're executing, and then once we have a match, withdrawing the action provider from their funding vault and then executing whatever this Wayroll script is. Hopefully that all makes sense. We also have different reward styles. You can either pay them for like we're going to say, okay, we're going to pay you to execute this recipe, and we're going to pay you up front, right? When you execute it, we can pay you at the end after your time lock has expired. Or we've got this third style forfeitable, which is you deposit in your wallet gets locked, but at any time you can unlock your wallet. But the catch is that you're going to forfeit your rewards. So your rewards would have been paid at the end of your time lock, but if you choose to unlock early, you can forfeit your rewards. So that kind of covers um, the different reward styles that you can have. Some storage, events. Yeah, market creation functions in order to deploy a new incentivized recipe. Uh, to create order functions. Um, we're taking fees the same way, but this time we're taking fees based on whoever filled the order. So when you fill an IP order, you say, this is the front end that brought the deal flow. They're receiving the fee. Yeah, these are all pretty self-explanatory. Kind of like your fill order functions are your taker function, saying, I'm going to take this offer. Uh, oh, if token address is 0, so if you say, so we expect that all orders have kind of a funding vault. So it's like, I'm going to deposit in order to have capital efficiency. You don't want your money just sitting idle in order to place these orders. So we have kind of this graph of you've got vaults that you're currently in, and you're placing orders on other markets where you might be depositing in that market or depositing into some other vault or executing some script. And when you place orders, you're earlier I call it collateralizing, which is slightly misleading, but you're collateralizing your order with some other vault. And so we're kind of expecting that you always are funding this order via some vault. However, if you are let's see where it is. I'm trying to find an example. If you pass a vault address of 0, you say, my funding, here we go. My funding vault is 0. Then what it does, it just expects that you're funding this via just tokens in your wallet. We're not going to expect that your tokens are in some vault somewhere. We're just going to know that they're in your wallet because you passed a funding vault of 0. And here at the end of our fill IP order function, we have this execute wayroll script, which is going to, call your wayroll wallet and execute that action. We also have this forfeit function. So for the forfeit behavior that I described earlier, where, I get my money back, I regain control of my wallet, but I forfeit all of my incentives. We've got a helper to withdraw you, fee claiming functions. Actually, I think this is how you claim your locked rewards. If you say, okay, you don't get your rewards until after your lockup expires. And then we have to show you more of Wayroll Wallet. Since we're using clones with immutable args pattern, we're recovering all of your variables like your fill amount and how long the wallet is locked. We're recovering those from the bytecode of the clone, which you don't need to know how that works if you're not familiar with clone with immutable args pattern. But basically, you can recover your different arguments that you have passed via these functions. And then we've got our execute wayroll function. This calls a wayroll script, manual execute wayroll. So maybe your wallet is unlocked and you've got you haven't been able to withdraw your funds. So you're going to call a script manually in order to get your funds back out, or because the given withdrawal script didn't work, maybe, or maybe you're not even going to bother with wayroll. You're just going to execute this straight as call data. You're going to make sure that your wallet isn't locked and then execute some function call directly in order to recover your funds. So this one is the one that the order book is calling for your going to call this in order to take your action that's been defined in your market. And then these two are more kind of like emergency fallbacks, where if something's gone wrong and you've got funds in this Wayroll wallet and you want them out, you can call these in order to do whatever you need to in order to recover those funds. But you can only call these functions after your time lock has expired. And there's your forfeit function that I mentioned earlier. And I think that's just about everything. Yeah, we have. I think the only contract I didn't mention is this points factory contract, which is very, very straightforward. This is just what's deploying the different points programs. It also has a mapping that tracks all of the points programs, so that when we, say, hey, I'm incentivizing this with this token, we can check this mapping and say, oh, that's actually a points program. We won't try to treat it like an ERC20. But yeah, I think that covers just about everything. We have a colossal number of like fuzz tests, which you guys are free to look at. It takes quite some time to compile. None of the libraries are under scope. We do have the Wayroll one is the only one that's particularly interesting, but out of scope for this contest. And yeah, I think that's pretty much all that it makes sense to cover for now. Didn't notice any questions.
I actually have a question for you, but I
Please.
will also remind everyone else if they have one to drop it either in this chat or in the Royco general chat after the fact. But my question is there any like particular area within the code that you guys are, particularly excited and or nervous for people to kind of dig into? Like, is there a particular area that you think is like a little bit more complicated or anything like that?
I think so we did already kind of have this pass through some initial kind of work in progress audits with Spearbit, and the only contract that got rewritten completely was this ERC 4626I. So this is all code that has kind of been written in the last like 2 weeks. And so this is the part that I'm most considered or concerned about kind of having vulnerabilities, because it's all new logic that hasn't been checked very meticulously. So if I had to recommend a good starting point, I would recommend starting with the OC4626I, making sure that the staking math is all correct, and then you'll also be able to kind of have good context for the rest of the protocol to go extend after that.
Nice, that's perfect. Love some extra intel. It doesn't look like we have any live questions, so I will let everyone get back to their afternoons, but I really appreciate this, Jack. I think just another note, I'll be uploading this to the Cantina YouTube straight after this is done, and I'll drop that in the channel as well, so it'll be accessible for everyone moving forward.
Great, that sounds great. And yeah, like you said, if anyone has questions, please reach out to me in the Discord. I'll be watching, answering as much as I can. Again, thank you all so much for your time, and I will be talking to you shortly.
Awesome. Thank you so much. Have a good day.